Okay, good morning everyone. Welcome to our panel discussion. This session is about decarbonization. And I would like to thank all the panelists for our discussion today. Please let me introduce our panelists one by one. So the first one is Dr. Saranya Ping-on from PTT Public Company. The second one is Mr. Thomas Masua from GTRA and Siemens. Okay. The third one is Mr. Hiroaki Shima or Shima-san from JR Freight. Okay. And last but not least is Dr. Wisan Leela Viwat from NTEC. Myself, I am Wichai Siwakosit from Kasetsart University. I'm going to be a moderator for you today, okay, for this session from 9 to 10:30. So now the decarbonization is the topic that a lot, I think in general public we are well aware of. But of course, railway sector is already a very green kind of transportation. So today we have interesting mix actually from our, from the presentations from our panelists. So what we are going to do is that we are going to ask our panelists to present some of the slides relating to decarbonization, okay, and afterward we will have the panel discussions, okay, and then we will have some general questions from our audience here. So let's get started. For our first presentation, it's going to be from Dr. Saranya from PTT, which is about the activities of PTT on decarbonization.
Yes, and good morning, ladies and gentlemen, again. And thank you very much for being here in the early morning in the center of the city today to be the decarbonization together. And today I'm the PTT representative to show you how the PTT do the decarbonization pathway for this country. The first of all, the PTT visions, we would like to power link lives with the future energy and beyond. We had the main two parts, firstly with the future energy, and another thing is like the beyond, but all the things that we move forward to the decarbonization. And how can we move forward to decarbonization on that vision? We have the net zero emission target on 2050 is farther than Thailand country 15 years because on the Thailand we had the targets on 2065. And how can we do the net zeros on our company? We had the 3P pathway on the right hand side, as you can see on the screen. The first P is the pursuit of the lower emissions. It means we would like to reduce the greenhouse gas emission 15% by 2030 by the initiative projects, right? The carbon capture and storage, carbon utilization, and followed by the portfolio transformations. As everyone know here, we are the oil companies, so we would like to transform to more clean energy, like the renewable energy, and we invest in the renewable energy more. We had the targets on the renewable energy 12 gigawatts by 2030s, and for the green portfolio with the future energy and beyond with the 32% of the capex by 2030s. And the last one, we would like to be friends of the environmental or be friends of the nature with the reforestation. We had the targets for 2 million lives by 2030, but right now for the PT itself, we achieved this target for 1.1 million lives already for this year. Coming to like the initiative project that has the big impact to reduce the CO2 in our growth. The first one will be like the CCS or the carbon capture and storage. This project will be the pilot project. Will start by 2027 by the PTT subsidiary that's called the PTT E-Pre, and followed by the CCUs. We try to study on the way to utilize of the carbon dioxide, like the use at the valuable product like the sodium bicarbonate, animal proteins, methanol, and so on that can make more the valuable product thing to the markets. And followed by the renewable energies. Of course, you know that like the very popular in Thailand right now, like the solars and the somehow of the wind, yeah, something like that, and combine the clean fuels. That is very hot topic today. Is about the hydrogen that can use like the energy for the many economic sectors like the transportation. And the last one is the reforestation. As I said before, we have the targets for 2 million light, yes, to plant the tree for Thailand. And this is like the overalls of the initiative project and what about the products of the PTT that the PTT innovation instill support for the PTT group to launch to the markets in Thailand. Of course, we are the oil leader in our country. In this country, we are the leader in the biofuels and the bioethanols. We launched the product, the first one in the market of the Thailand for like the B7, B10, and the B20 to the markets, and also the many kind of the gasohol, as you can see on the product here. All of this is made from the bio. Of course, the bio is the less CO2 emission, yes, to the environmental. That's why we try to develop on this for the support the existing technology, yes, and for the aviation. What we gonna do? We think about like the biogas or the SAF or sustainable aviation fuels is very important things to reduce the CO2 in this sector. So we have like the initiative sign the memorandum of understanding with our PTT group to the study and develop and also the invest for the biogas production in this country in the future. And the last one is all about the hydrogen that can use in the many applications. Yes, come to see the detail. This is like the examples of the project that the PT Innovation Institute do for the road transportation. This is the example of the biofuel tailpipe emission reductions that we test in our company. As you can see on this screen, for the B20, we had the 4 pillar, right? The first one, the yellow and the orange one will be the Euro 4, and the green one and blue one will be the Euro 5. And the more biodiesel, as you can see, the more reductions of the smoke and the particulate matters, and the particular number is mean the more clean emission to the environmental for the biofuels. This is show you the result. And of course, for the B20, it means the more bio, it can reduce more of the CO2 emission as well. It's about a 15% reductions compared to just the diesel itself. Come to see in the aviation. We are the first one to cooperate with the Thai Airways on the last 12 years ago to use the biogas that's produced from the used cooking oil in the first of the Southeast Asia and the first of the Thailand as well. That's confirmed is the biogas is can save for the existing technology for the aviation technology right now. And for this year, because of the ICAO standards and all around the world has to force to use like the biogas as the CO2 reductions, and how can we provide the biogas in this country. As I said before, our PT group had signed the MOU to study and develop and invest in the SAF in the future to support the biogas in Thailand for the Thai as the aviation hub for this region. And why we use the used cooking oil on that time. You can see the right cycle assessment here. On that, I highlight on the yellow one that we call the UCO. The CO2 reduction is allowed 80% when you compare with the jet from the fossil fuel. For the hydrogen, what we doing for the demonstration project, the first hydrogen refueling station in Thailand that is opened last year on the November. See here we do with our partner with the PTT, OR, Toyota and the BIGs. We use the byproducts of the hydrogens from our refineries and the purifications and use to the end user. Here this is like the our activity, we have the two of the fuel cell car in Thailand right now used at the Utapao Airport limousine. That it means everyone in this country can use and that can knows more about hydrogen for the fuel as transportation. And why we use the white hydrogen? Because you see here the CO2 reduction is more than 80% of the CO2 reductions when you compare to the combustion engine in the same size of the cars, and also the CO2 reduction is more than the EV right now allow the 60% of the raise CO2 reductions, because the electricity of the Thailand is from the grid mix is produced from the many kind of fuels like the LNGs, diesels, and the coals. That's why the hydrogen from the byproduct is more cleaner here. And this is the actual usage. As I said, the CO2 reduction is much more, but for the current state that on the last rise of this slide, as you can see, the CO2 reduction, we use the totally right now the hydrogen allow the 800 kilogram of the hydrogen for the operations from the August. It means we can reduce CO2 allow the 15 kilogram of the CO2. Yes. And coming to the last slide, what about the railway sector that we do? We try to support the low carbon intensity fuel with the match with the current technology that the railways in Thailand can use in terms of the B20. On that time, this is like the sample of the one project for the Ballroom routes or the railway sector. That the B20 is can reductions of the CO2 allow the 15% when you compare diesel. Yes. That's all for me for the decarbonization for pathway of the PTT, and also support Thailand to move forward to the net zero together. Yes, thank you.
Thank you. So we still have a couple more minutes to take questions on the PTT part. Very nice timing, by the way. Thank you. So, okay. First of all, I would like to ask. Probably the first question will come from me. So I would like to ask about the biodiesel fuel that PTT is currently supplied to the State Railway of Thailand. So is it the same kind of B20 that we also provide to the trucks? I mean, at the gas station?
Yes, it's the same. Yes, but on that time for B20, that we do this project like the initiate projects before that's run to the whole country.
Oh, so
yes.
This is the pilot before you actually start distributing the B20 to other cars.
Yes.
Okay.
Yes.
Okay.
Yes.
Okay.
But it has like on that time it had some fee, some engine that's match with the B20 use it as well.
Okay.
Yes.
Okay. But of course some engine might not be able to use B20. Yeah.
Yes.
So it will be subjected to some modification.
Yes,
Okay.
that's why we start to like doing trades on this project. Yes, to see can it use B20 or not? Is that problem, or how can do maintenance it for the engine? Yes.
Okay. Good. So, Jeffrey, are you still having the diesel locomotive? Yes. Still? Okay.
Yes, still have. So I checked the B20. So I would like to study about the B20.
Good.
And if possible, I would like to introduce to Japan colleague about this fuel.
Okay. Interesting. Good. Okay. So I think at this moment I will move to Thomas. Okay. I will switch the slide a little bit.
Ladies and gentlemen, I will talk about more technological aspect of the railway itself. Mobility solution for a better tomorrow. By the way, you see here EcoVadis platinum medal, which the German suppliers, in this case Siemens, has won, being in the top rate of the railway industry. In 1% of the top participants, winning that, ensuring that that the railway achieve zero carbon neutral mobility operation. And today I'm representing GTRA, German Thai Railway Association, by the way. Now, what I will be presenting to you is the opinion of our Thai-German collaboration. Yeah, this is not one-sided opinion. I need to push this button, yeah? Okay. So this is the, can you activate, how to activate this one?
Oh, this is a PDF. It's PDF, so it's not PowerPoint.
Ah, it's not PowerPoint. Because I had this kind of movie.
Yeah, I know.
But this is not taken. We apologize. There was a very important movie to shake everyone a little, but we have to skip it. Yeah.
So
we will do it in by other occasions. Definitely, if you look to the changes and challenges of the population, growth of the population, 70% will be living soon in the cities. There were 3 times more passengers, and the global energy demand is increasing by 30%, and so on and so on. Green gas global emission will be also in the transportation increasing if we don't do anything. You have seen, some of you yesterday, presentation of Katrin Luger from UN. This 25% of contribution of transportation is concerning, but it's only, I say only 25%, but everyone has to contribute to the zero carbon emission or neutral carbon emission. So UN defined these goals, sustainable development goals, you see, just as a reminder, and everyone, including all the industry, mobility, railway, are following this demand. And what is happening on the German side, by the way? No? If you look to the German companies as Siemens, already, if you're comparing to the operation 2014, it is not about operating, reducing greenland emission. It's also in operation. It's about how the entire operation also of the manufacturers, of the industry, becoming carbon neutral. We are always looking on the end. Battery-driven trains, hydrogen trains. But what's happened before? We never look at them. Please, this is the opinion of Thai-German colleagues. It's not my opinion only, because we are not saying the truth. We have to talk about the truth. The truth are, we are coming only on the end point. We want to electrify EVs in Bangkok. Would you solve the traffic congestion? Change all cars on the street to EVs. Would the traffic move in Bangkok? Where the energy is coming from? Thailand has less than 20% renewable sources. Yeah. Okay. Also, yes, you will continue use Victorian grid. Bangkok will be not moving. Will be traffic congestion. I take this example intentionally because everybody can imagine what is behind. How to produce environmentally friendly batteries, what to do with teratons of batteries, which will be available soon, because as soon as the capacity is below 70%, you cannot use them for the EV anymore. And what to do with that? Who has a fantastic and reliable concept of recycling? Yeah, so that's why 46% of CO2 reduction in our own operation. That means how we do produce, how we do operate our offices, everything, it must be carbon neutral. And we have achieved already 46%, almost 50% versus 2015. I will say how. Investment also in the future reduction. For example, with our electrification measures, we're going to change our cars to the e-cars. But again, if the e-cars and also modern buildings are also important, by the way. When we continue, for example, in Thailand, we will not stay in Chanisara anymore because this building is not environmental friendly. How it's operated. That means that is also the drive to change also building automation, go for the environment friendly buildings. Also electrification measures, take a fleet cars. Also those have to be powered by green energy. And that's why also you see on the 77% of our operation and of factories already utilize green energy. That means renewable sources. So, but now coming back, this is not only on the manufacturer side, on the user side. If you see to achieve that, the authorities are required. The interfacing, this must be balanced by authorities in terms of economics, environmental impact, but also social impact, because this is also important, no? And ensure seamless, safe, reliable operation also for the transportation. That means complete mobility ecosystem have to be taken into account, enabling profitable operation because operators want to earn money, saving natural resources. We are talking about the energy, where it comes from, and how to use that energy in an efficient way, promoting shift to the public transport. Katrin Luger spoke yesterday about that, how to attract people to use railway, for example. And we spoke today with one of the organizer. He is not here. She is not here. She said she used the car, but she could take a BTS train, but she has not taken. Yeah, I say, oh, that you have to come to this session to listen about. But there was always excuse. She said, I have excuse because afterwards I have to go 40 kilometers in other direction. I don't have train. How we attract this lady and ourselves to use the public transport? Yeah, it's not so easy. Look yourself. Are you willing to use the rail with the solution you have here? So for that one, you need also technology provider, you see, for the railway infrastructure, turnkey business, rolling stock, rail services. But what is important? Intermodal solution, softwares, when the means of transportation must be given, but have to be connected online. We are not talking about Google Map. It's not enough. We are talking about something which is optimizing, as a software is optimizing usage. Means resources. Resources are given. Very often the operator is going, I need more trains because I cannot accommodate passengers. Why not go to dynamic, flexible timetables, allocating, for example, resources where they are needed? And for that one, you need digitalization. You need a software. As a software where the connectivity is given for the operator, but also for the passenger, door to door. Examples. The best you go to the examples. If you talk about the entire chain of this energy usage, it's important to see, let's go to the endpoint, train. Because we say a manufacturer had to provide a solution which is environmental friendly. The trains, manufacturing of the trains, operation of the offices and factories produce carbon emission. Definitely, yeah, this has to be reduced. But when the trains are running, they indirectly produce carbon because they use energy from PTT, and anybody else, no? And the question is, how clean is the energy consumption? Well, how is it? So here you have an example that by this model you see 100% in Austria. Austrian railway achieved by the Rayjet 100% neutrality. Those trains are 100% powered by renewable energies. Very unique, and we know to achieve this reduction of the global temperature decrease. We need to go for carbon neutral mobility. Example from new technology, high speed. In the first room, they are discussing again now about high speed, but also new model are required, not the traditional train as running today. New technology, lighter construction, different car bodies, more optimized in terms of consumption. 30% of consumption is Velaro Novo, by the way, which leads to adequate reduction of more than 1,000 ton CO2 per train, and comparing to the traditional high-speed trains which are running today, and less investment because it's getting better. The same for the locomotives. You see also new locomotives. This is dual mode locomotives, diesel, electric. You say, why diesel again? Why diesel again? If you go to Germany, only 60% of the network in Germany is electrified. 60%. And this a liberalized market. If somebody gate concession is operating, and say, I have to operate two different areas, electrified, not electrified. He's investing in diesel train and running diesel train or electrified tracks, because then one day he has to go not electrified track. What does it mean? He's polluting permanently. But having this dual mode, he can change the operation mode depending, I'm going on the overhead category or I'm going non-electrified area. And then in this way, the operator is reducing also emission. You see here, 950 ton. per year and train comparing to the traditional diesel. That will be the solution not only for the biodiesel, but also having this dual mode. It costs more money, by the way, but it pays off. Also, you look on the right side for commuter trains, and this is interesting topic, very sensible, because you have heard yesterday what the permanent secretary was talking, development of the battery-driven trains. Battery-driven trains or hydrogen-driven trains are good for those areas as a niche solution where it's not electrified. Electrification, there's no option to avoid electrification. I will be the first one to look for the award for the Thai people, a researcher developing battery trains with heavy cargo is running with batteries, sustainable. Yeah, okay, good. But please, also here, Thai, German, please advise properly politicians to understand that technology has limitations. Not today, this is not today possible, but it is good technology with hydrogen, with batteries, and these commuter trains are running, for example, in Germany, where this niche operation can be covered. And it's not only Siemens, also Alstom, other manufacturers do the same, providing those trains and they're running. So that means we ensure life cycle management from the manufacturing, digitalization, connectivity, operation, provide this respective solution. We have to look in a holistic way on this picture, not on the one-sided. One example more. Here you see Velaro as a high-speed train. This is still the traditional train, which is not so optimized as Velaro Novo. But you see here, the Spanish operator introduced this Velaro, high-speed trains running between Madrid and Barcelona, for example. And today there is no air traffic anymore. No, you cannot book any plane because those trains are much more reliable. You need less time, less costly, and of course high efficiency. But this can only work when you convince the passenger to take the train, and they're convinced because 100% availability. Yeah, it's incredible. The trains have delays. You have to wait. You're in the airport. You are busy. You take your coffee first, second. Here you're sitting here. You take your coffee while you are traveling, and you see increase the demand by passengers shows very clear. This pays off and we have less carbon. What else? Digitalization. In the middle here, Rome, we talk about digitalization because, remember Katrin Lugar, without digitalization, we cannot make the carbon mobility carbon neutral. Optimization. Here we're talking, for example, interlocking, the railway optimized way, how to connect on demand, utilizing resources, optimized way, sending the trains, in the most efficient way from A to B, but also interlocking in the cloud, for example. Digitalization allows also to go to the cloud. It's always the question about cybersecurity, but this is manageable. This decrease the needs, for example, for the hardware, less hardware. Only one data center. And the hardware doesn't belong to the operator, it belongs to the service provider. Yeah, you use the service provider, you have a less hardware, less copper, fiberglasses, and this become optimized and less. If you produce less, we produce also less carbon. So that means improving efficiency, also automated operation. Also this ATO, which you know from metro here in Bangkok, for example, it goes to the main line where you decrease headways, where you optimize the operation. Also for traffic, for passengers, but also for freight, by the way. It's interesting for the freight when a lot of trains running and this majority of the let's say, economical values are in the freight. So, but then also how to convince this passenger to use it. First, you build the options to cover all the means of transportation, but connect them properly. And this is mobility as a service. And here we're going for digitalization. I believe I don't need to elaborate. The discussion here is on the right side. It's an unavoidable. And also, once again, coming to the energy generation, power generation, biodiesel. But look at it is very clear. Even in Europe, the solar power plant are used for example, here in Sacramento, a factory in the US, but also in Vienna power plant, in other manufacturing plant, we use this own power plant where we generate renewable sources. And again, sustainable future. Sustainable future. You see here, by the one, we consume resources of 1.5 globes today, and we continue will be 2, 3. You see the statistic from UN, if you look exactly to that. That means we are wasting our resources. We are consuming that what our children will be needed. Tell your children that you use that what they would need in the future. You consume, you tell them, I take your oxygen today, tomorrow you have nothing to breathe. Yeah? Explain them that that we are doing all, and also we, as we are sitting here, we are not doing differently, because we are talking about permanent end solution, EVs in Bangkok. But we take this only examples, not talking about. We are talking about a part of alternatives, but we are not talking about the complexity. Sustainable chain supply management. Also, here we have to force our supplier to take this, and this is who can enforce it when not German Thai Railway Association, for example, enforcing all the suppliers in Thailand or also international to follow also the stream. Yeah, they have to be sustainable also. Provide. That means we have also obligation not only saying we are manufacturing, we are clean, but we are buying a product in our supply chain and utilizing service providers which are not clean. So. Thank you very much. From my side, I'm happy to answer questions.
Any questions for Thomas from the floor?
Thank you very much. My name is Nuong from National Energy Technology Center. I just want your perspective because as much as I personally would like to promote hydrogen in train also, but we heard some mixed news from German, whether Alstom is going full stream, and on another page we saw there's some setback by some of the purchasing maker. I am not sure what kind of standing between from the German perspective, whether from a government side, regional side, or from the company side. Thank you.
Interesting question. Just give you a little confidence about Thailand, because sometimes we're looking on Thailand and discussing how politicians making decisions, because the authorities have to give the guidance. But also in Germany, it's not different. Yeah, it's not different. Germany is getting lost. With all these approaches, they are pushing very strong EVs, but energy is not coming from renewable sources. Yeah. Yeah, it may be higher level or degree of renewable sources, but it's not a big different. There is no resolution for the manufacturing topic, where we produce a lot of carbon dioxide, where there is no solution for the recycling. Also, the drive for hydrogen. This is always in a moment isolated approaches, and the entire pictures, holistic picture is missing. It's simply missing. And this is not about Thailand. It's about entire world. And Germany, obviously sophisticated country, also missed this point. And we are as we are in our associations, we are discussing that also on this level. And that's why what you heard is the reason for that is that this holistic picture has not been seen. That now, considering there are, I don't know, millions of cars already in Germany, EVs, which are registered, but there's not enough charging stations. The issue is with recycling batteries. What to do with the batteries which are not usable anymore? The concepts are not given. And we know when we produce batteries in the way as we produce, we simply destroy the environment. The sources of the components are also questionable, from the child slavery to destroying the environment. For example, in the desert of Peru, you know the stories, and looking for the better batteries which are environmentally friendly. This is not developed yet. Then manufacturing way. Then to see how we are going to operate those EVs later on. There are also a lot of questions, a lot of issues regarding fire hazard. You have heard what has happened also in Germany, you heard about this accident on the ferry a few weeks ago. The ferry there was a big disaster because it was full with EVs, and one of the cells got a short circuit and triggered a fire in the entire ferry, and they could not extinguish. Yeah, there was several days of the story. As you see, there's a lot of question about that. And there are also ideas about go to hydrogen. The trains definitely are good for the area where you have renewable energy sources. There is collaboration with, for example, German Railway Energy. There's also subsidiary producing renewable energy. That means wind power plant connected to electrolysis manufacturing plants for hydrogen and supplying trains, no? And also mobile supply devices for the trains. Everybody's saying this is good for the area where we would put the diesel trains only, and this is from the power efficiency still only for the passenger operation, not the freight operation. That means, in summary, the world is still looking for a solution.
Okay, in a nutshell. Yeah. Okay, so our next presenter is Shima-san from JR Freight. So I will help you change the slide.
Okay, hello everyone. Good morning, everyone. Sorry. Oh yes, okay. Okay. Today, I would like to introduce about our experience in Japan. So from this slide, I will talk about only in Japan. And first, I would like to explain about what my company is. My company is a freight company in Japan. There are 6 passenger company, 6 passenger JR company, and 1 freight JR company in Japan. And I am from JR Freight Railway Company. And main line in Japan owned by JR Passenger Company. So to operate the freight railway, we pay access charge to JR Passenger Company, but less of facilities like locomotive, wagons, containers, and railway container yard we own. And as you can see the square, in the red square, we operate freight train in Japan, and we operate container yard, freight station, and handling various containers, not only dry containers, but reefer container, tank containers. And also, we ourselves maintain our rolling stocks, especially locomotives and wagons. And this is my company's specification, but the detail I will explain the afternoon session. So please come to maybe room B. Yeah, please, I will explain about the details. And next is myself. I'm from JR Freight. Sorry, wait. Okay, my biography, and I'm expert in the mainly train operation, freight train operation, and container yard operations. And my company started Bangkok representative since 2021, 2 years ago. And my mission is developing freight railway business, not only Thailand, but also neighboring countries in these GMS areas. Okay, and next, from this slide, I would like to explain about our challenge in decarbonization. And I will mention the 9 topics from here. Okay, and first of all, I introduce about environmental characteristics of freight train in Japan. CO2 emission of freight railway transport is about 1.11 in Japan than commercial trucks. So railway thought to be an environmental friendly modes in Japan. Not only passenger, but also this is freight train. And and in JR Freight, every year we publish environmental impact data every year. We calculate inputs such as electricity, oil, gas, water, paper, and outputs such as CO2 emissions. Because we conduct business activity not only JR Freight, but as a group. So not only main company JR Freight, we publish data of entire group, about the entire group. And Now, JR Freight aims to achieve net zero CO2 emissions by 2050. I will introduce from this A to D, A to sorry E. I will introduce activity from A to D. First is the next slide. First is a locomotive. In general, most countries, railway operators simply select and purchase locomotive from manufacturer catalogs like Siemens catalog. Right? Okay, yeah. But JR Freight has been working with mainly Japanese manufacturers, and we develop railway rolling stocks by ourselves with manufacturers. For example, Hitachi or Toshiba or something. Yeah. So for example, okay, this is an example. The left one, shunting locomotives. We spend a long time idling with waiting the train coming, the train arrival. So for this reason, we develop a hydro locomotive named HD300. It combines a small diesel engine and a large capacity lithium-ion storage battery. And next one, this is for shunting. And next is for diesel locomotive for main line. The diesel locomotive main line named DD200, the center one. It complies with Japan's Tier 2 engine exhaust gas regulations, and we use inverters, a hybrid silicon carbide element with high power conversion efficiency. But in Japan, we mainly use electric train because passenger company electrified their main lines about 70% in Japan. So we produce a new version of locomotives, EF510, 510. It is new equipped with AC regenerative braking to reduce environmental impact. And next is in freight station. We use forklift equipment to lift on, load on, and load off, unload from wagon to wagon, our containers. And we use a forklift with low CO2 emissions. And some freight station is in urban area, so we introduce soundproof forklifts for the urban area. And also we use biodiesel fuel, but it's not diesel. It is made from edible oil and euglena. And now we use only for trucks within freight stations, not main line now. Yeah. And also lighting is used in freight station in Japan. We operate freight station 24 hours a day, 365 days a year. So we need more and more electricity for lighting. So we currently replacing mercury lamps with LED lamps. Okay, next. Next one is our future. This is our future. By collaborating advanced technology, we are pursuing labor savings and operating efficiency in freight stations. So now we are developing systems such as truck platooning within the freight station or forklift driving support. Now forklift is driven by humans, and remote control of shunting locomotives. Some initiatives such as truck driver application are actually working in our freight station now. And not only using electricity, we now create electricity in our facilities. For example, renewable energy covers the entire amount of the common area during the daytime hours at our warehouse named Tokyo Railgate East. It exists in our freight rail station in Tokyo. And not only main company, our group company work together and introduce renewable energy, including we have so many lands, idling lands, so we need to use the idling lands. And this is another activity, not the technology, But in March 2022, we issued a first corporate bond named Green Bond. Our bond have two types of issue date, 10 years, 2 years. Issued amount is each 10 billion yen, Japanese yen, so almost 70 million USD. Green bonds are bonds issued for green project, such as I mentioned, Tokyo Railway Gate East, it's a warehouse. And we developed a green bond framework for green bond issuance. Our framework was received the highest evaluation from outside organization. And this is number 8 topics. In transporting various things by rail, we started switching from trucks to rail. So many things, but this example is for trees. Trees that are transport long distance from southern Japan to the Tokyo metropolitan areas. We need to keep quality of trees. So a unique container developed for transporting. So trees are used for this. So trees, we can keep the quality of trees during transporting. This is an example. And last example, this is a mark named Eco-Rail mark. In Japan, the government established the Eco-Rail mark in 2005, almost 20 years ago. The purpose is to appeal to general customers, not B2B, this is a C customer, general customers. So the appeal to customers, the product and companies that are freight railway transport, they use freight railway transport. Currently, 187 products are certified. Also, 98, almost 100 companies are certified. So if everyone change business card with me, we can see the Eco-Rail mark with my business card. Yeah. And JR Freight also a sponsor. So we participate promotion event held across Japan. So we are promoting environmentally friendly freight rail transport. So if you purchase a Japanese product in Bangkok, for example, snacks or drinks from Japan, yeah, you can see that this mark, Eco-Rail mark. Yeah. And last slide, this is a condition for Eco-Rail mark certification. It's an example. Products are certified to be transported by rail at least 30% of the distance of over 500 kilometers. Yeah, and another rule exists for company certification. Okay. Sorry. Thank you very much. This is cut off from my presentation.
Okay.
Thank you very much.
Okay. Thank you very much, Shima-san. Now we can take some questions from our audience. So anyone has anything to ask Shima-san?
Hi, Noah again from Intech. So just keep discussion active in this room. Thank you very much for your kind presentation. In your very first slide, I'm very impressed by the fact that you showed that the CO2 emission for rail is lower than the ship. Here. Right. This is the Japan one, right? For
yes,
fiscal year 2021. Can I ask what is the emission factor that you use to evaluate this emission factor? Because I think I'm pretty sure that rail you mean 100% electric, right? Compared to ship where you have to use like a marine oil or bunker oil, those kind of thing. May I ask what is the emission factor for Japan? Like some number, do you know offhand, like kilogram CO2 per kilowatt hour? So that, because usually for me, right, the ship would be the lowest energy consumption per ton kilometer, but this is quite different, like 50% lower. Thank you.
Thank you very much. Good question. I think there is a two factor for this image graph. First is what we use. For example, for trucks, for ships, or for trucks or ships, we use oil. And on the other hand, for rail, as I mentioned, in Japan, almost 70% is already electrified. And in Japan, electricity is produced from oil, coal, and nuclear. But for rail, JR passenger company, JR passenger company provide electricity to JR freight. So this is from where JR passenger company get electricity. Yeah, and several passenger company has their own power plant, and coal power plant, oil power plant, and also sorry, I don't know the English name, but they have some dam because Japan has so many water disasters, so they have a dam, and water falling from the dam, they produce electricity. Sorry, hydropower. Yes, hydropower electricity. Yeah, so this is so clean energy. Yeah, this is why one factor why the rail is environment friendly. And second factor is efficiency to transport. If one truck, no, sorry, I changed the explanation. Our train can transport almost 50 containers in one containers. But truck can, in Japan, truck can transport only one container. In Thailand, maybe one or two containers, but in Japan, only one containers. Yeah, but we can transport almost 50 containers. This work efficiency is effect to this result. That's my answer. Is it okay? Okay, thank you very much.
Okay, thank you. Okay, so I think we will move on to Dr. Visan from Intech for his presentation.
Okay, good morning and สวัสดีครับ Again, my name is วิสาร ลีลาวิวัฒน์ I'm from National Energy Technology Center or Intech. So today I would like to talk about the hydrogen technology for rail transport decarbonization because our topic is about the decarbonization. So of course, right now the global warming is a big problem for the whole world. So Thailand, we pray that we have the target to be carbon neutrality in 2050 and net zero greenhouse gas emission in 2065. In order to do that, we have to reduce the carbon emission by 40% in 2030. This is our long-term development strategy for decarbonization. As you can see that this is we have a goal to be decarbonization and be carbon neutral, but how we can achieve this one is still in the problem because right now most of the carbon emission is from energy sector, and 1/3 of the energy sector that produce the carbon emission is the transport sector. So transport is one of the biggest sector that produce a lot of CO2 emission or greenhouse gas emission. And the railway transport have the very unique characteristic. It is one of the most efficiency transport. So in order to decarbonize, if we use more railway or train, it's already help to decarbonize itself because of the efficiency. As you can see here from the IEA, you can see that the train here is the most efficiency one. So I will talk about the hydrogen. So why hydrogen? Currently, what we produce energy from is we produce from oil, coal, and natural gas. In order to do that, to produce the energy, we produce carbon dioxide as its byproduct itself. As you can see, because it's a hydrocarbon component. And in the future, as Dr. Saranya from PTT said that hydrogen could be the future energy because if we can produce the energy from hydrogen, it is cleaner because the byproduct is just only water. So no carbon dioxide in hydrogen bond. And you can see that for the arena study, for the major technology for decarbonization, hydrogen is one of them, but it's not the majority is for the energy efficiency and renewable, of course. But hydrogen is one of the main technology that can use for decarbonization. It will take out about 10% of the carbon dioxide. So each year, right now, we produce about 37 gigaton of CO2. This is a lot number. So we have to, because this is a big number, so we don't have only one solution that can reduce it all. So we have to come up with many solutions to fix this problem. Some might be suitable for some case. So that's why we need to study the way to decarbonization in many methods, not only just one way. So hydrogen can use for many kind of application. It can fulfill the energy sector, and it can be used for the industrial and transport as well. As you can see here in the left picture here, that the hydrogen can produce from the grid electricity if we have the surplus energy of the renewable. And to have the hydrogen, we can use the hydrogen for the fuel cell electric vehicle or fuel cell train. And we already use hydrogen for upgrading our petroleum product or synthetic fuel already, and we can use the hydrogen to upgrade the biofuel as well. And the hydrogen can be used as a fertilizer for the with the ammonia, and it can be used for the reducing agent for the ion industrial as well. And if we have more too much hydrogen, we can put it into the gas pipeline and burn it as a burning fuel as well, or we can use hydrogen to produce the electricity from the fuel cell. And from the right hand picture here, that is the study from ARENA, what hydrogen should be used for. And you can see on the big rectangular here that this is the product that hydrogen should be used for, because right now hydrogen still is more expensive than other energy sources. So we should use it for more variable or the thing that hard to change for the electrify, like a long haul transport, like freight or ship or steel industry. And the trend is it kind of in the middle, that what should we do should we go for electrification or should we use for the hydrogen? Because I think it depends on area of it, or if the electrification route is already existed, so we should go with the electrification. But what about the route or the railway that there is no electric? I think hydrogen could be the answer for that. Especially for Thailand Railway, we have almost 40,000 kilometers of rail route, but we only have about 4% that electrification. It's just only in the Bangkok area. So Thailand is, with have very behind in many countries. We are not advanced in the electrification rail. So right now we mostly use the diesel electric train. So for the green power train, right now that okay, this is for example, I will present you the two green power train method. The first one is going to be hydrogen power train, and the second one is be battery power. That is from EA, and the first one is hydrogen power from Alstom in Germany. It can run about 600 miles or 1,000 kilometers. So the range is comparable for the diesel electric for the single tank of hydrogen. But for the battery train, the range is quite short. It's about 150 to 200 kilometers, and it uses quite a big amount of battery. It uses about 4 megawatt hour of the battery itself. As Mr. Somad said that if we use a lot of battery, so how we gonna deal with it when it's not being used, or how can we recycle? Because if we use it too much, we will have the problem, bigger problem for the recycling of the battery itself. So actually, as you can say that, we can use in many mode, by mode, dry mode, or something like that, reduce the amount of the battery that we need, and it can, use to transfer between electric line and non-electric line, something like that. So, but the problem in Thailand is just only 5%. So this one is still not a viable solution for Thailand, but it is good for other country to switching between non-electric and electric. So we use the battery when it's not on the electricity route, something like that. So because I'm not the train expert, so I will show you about the fuel cell battery vehicle and battery vehicle. As you can see right now, if you compare between the battery vehicle and fuel cell electric vehicle, I think it's similar to the train, but its scale is bigger. So the battery vehicle itself right now is for the small, for the short range. I think it's better solution for the decarbonization. But for the longer length, if you have to increase the battery itself is very expensive right now. It's half of the cost of the vehicle. And if you increase the larger size of the battery itself is very heavy compared to other type of fuel. So when you increase the battery, increase the weight, so what happened? You shorten the length. So if you have to run in very, very long length, you can see that battery electric vehicle is very expensive. Right now we have like a Day2 that run about maybe 300 kilometers. It's about maybe 600,000 baht. But if you go like a 600 kilometers, you have to buy maybe Porsche or Mercedes-Benz EQS, something like that. It's at 6 billion baht or something like that. It scale up dramatically. And the fuel cell itself, even though the initial cost is more expensive, but to add it length, the hydrogen is you just add more tank of the hydrogen, so it's not gonna cost a lot of money in the long run. That's why maybe for example, for the train or the railway, for the shorter length, for the not long, we could use battery for the train, but for the longer one, that from Bangkok to Chiang Mai or from Bangkok to South, it's about 600 to 900 kilometers. So we cannot use battery for sure. The fuel cell electric might be the answer for that, and because as Dr. Sanya from the PTT said about we have the fuel cell electric vehicle running for the Utapao limousine, and Mr. Thomas said about that. We use too much battery, and the Thailand electricity is still coming from the Victorian grid, something like that. It's not gonna help much. So I think right now for the smaller vehicle, the battery electric vehicle is a better choice. But for the larger one, for the train or something like that, hydrogen could be used for that. Because hydrogen powertrain is already used in public operation, like in Germany. I'm sorry because it's very small. And the green hydrogen could can be used. The green hydrogen can be produced from the renewable source like from solar or wind. And right now, the hydrogen technology already proved that can be used for the longer transport network. For the hydrogen conversion, so right now we use the diesel electric vehicle. We can use the fuel cell system instead of the engine or something like that to provide the power, or we can still use the ICE engine and change the tank from the diesel tank to hydrogen tank, so we can feed the hydrogen into the ICE engine, and it also can be run. But it's of these two applications have their own pro and con. The fuel cell electric is have higher efficiency, but the problem is because more of the fuel cell stack and the system itself. But the ICE engine have been proved for century that this is the one that the most robust engine for sure, and it's easier to convert. But the problem is the emission, because you burning the hydrogen with the air, not the oxygen only, because the air has nitrogen and it can produce NOx, and the NOx itself is not only just greenhouse gas emission, but it's also the toxic gas as well. So we have to careful about this one as well. So how to make the train is zero emission. I think for the hydrogen train, it has the advantage because of the train is fixing route, so we don't have to create many more hydrogen refilling station, and it can be retrofit, and it have the same range as the diesel electric, and it's zero emission, and it's also very efficiency. And this one is the example for the total cost of ownership. So how much does it cost if we use the different type of the rail transport? This is the case study from the Europe in the Spain itself, and you can see that the fuel cell is still a little bit more expensive compared to the diesel, but it is cheaper than the catenary electrification and the battery for the train, because even though the catenary is cheaper for the fuel cost, but the cost to invest to build the electrification line is very expensive, something like that. And this is just the last slide for the conclusion. So I think the rail sector should be, must be decarbonized. So we have to use the green technology for better for decarbonization. Either we use the green energy source, and I think the green business also an opportunity. Battery power can be used for the short range, for the electrification line, and it can use for the switching between the electric route and non-electric route. And right now hydrogen can be already been operated, and the hydrogen fuel is have to currently research that we have to looking for that, because we have to look up for the whole picture that even though if you hydrogen it not produce the carbon dioxide when you use, but how you produce the hydrogen, if that you have to produce hydrogen with the carbon dioxide or not, that is still the main challenge that we need to figure it out, that how we can make enough of the green hydrogen, or how we can transport the white hydrogen, something like that in the future. So thank you.
Thank you, Dr. Visan, for your presentation. So any question regarding his presentation from the floor?
Okay, so thank you for your presentation. And I have a little question about the green energy is the way to the decarbonization in the real in the one way. How could I say? In your opinion, is it possible to use the hydrogen in the railways of Thailand? And if it's possible, what the more challenge? What the more challenge for to make it possible?
I think it's possible right now. Thailand, as I know, Thailand have surpassed amount of hydrogen that we can produce from white hydrogen. That is very low carbon intensity compared to other, and it can be used in the train. But the most challenging way is because hydrogen is very easy to use, but it's not easy to transport. So we have it just only in one point, but how we can use for the whole Thailand way. We right now in the in the eastern seaboard Thailand, we have the chemical and petrochemical industrial that we produce byproduct hydrogen, and this one we have surplus amount, but how we gonna use in the Bangkok, how we gonna use in maybe Chiang Mai or southern part of Thailand. This is very challenges because it quite more expensive to transport the hydrogen right now. If we have to do the transform to one place to other, because the technology right now to compress it very high, it's like a 700 bar is still expensive, and I think that so we have to transport this one is very challenging in Thailand.
Okay. Some more questions?
Yes, my name is Bunchai Sangpetngam from Chulalongkorn University. Dr. Visan, thank you for your presentation. I have just one simple question on your presentation. Regarding to the battery train, you mentioned that the range is quite short, like limited to like 200 kilometer. But my simple question is, train can be shunting, can be we can decoupling and maybe switching the battery unit at maybe every 200 kilometer. So if we consider this option, would it be possible to use it for long haul, for long range?
Yes, I would say yes and no. Because yes, it can switching. So, but you have to lost one bogie or something like that in order to make it like a battery storage bogie. And if you have to travel for a long distance, to shunting it takes some time. It's not generally suddenly, but it will take time, like probably maybe half an hour to make it safe, because to decoupling the battery with the bigger size it's quite dangerous. You have to have the protocol to do that because this is 4 megawatt of battery cell is like the factory of the battery itself already there. So to decoupling, I don't think it's gonna be like a unplug it. It has to have the protocol to do that. So it's not just only 5 minutes for sure. And that could be do that. And then you have to have your own facility to decoupling that thing. And I think even cost more. That's why I could say it's possible, but I don't think it's feasible.
Okay, so I think we come to the final rounds of some sort of questions directly from me to each of you, and then of course we can join in to share our comments on the questions as well. So the first question I would like to ask Dr. Saranya from PTT is that why is decarbonization important to your organization?
Yes, for these questions, but I think as everyone knows, we are the state-owned enterprise. We have to align with the government policy that travel to decarbonization. And the second thing is, but it's very important because we are the largest oil company. So we have to do like the low carbon intensity and to make the good thing to environmental and to this country. Yes.
It's actually when I saw the campaign from PTT for net zeros and all that, I was very impressed. Yes. with I mean, of course your intention, and there are lots of challenges to conquer as well. Yeah. Okay, the next question I will ask Thomas about the train itself. So of course we know that trains is already eco-friendly, but how can we make trains even more eco-friendly? How can we do that?
Yeah, when we don't talk about the holistic picture, only one solution. When train using the energy is indirectly producing carbon dioxide, because the question where the energy comes from, but also the train itself, assuming that energy is clean, coming from the renewable sources, the usage of the energy in most efficient way. That means economical utilization, rated power, and to which extent the energy consumption will be reduced. That means energy consumption is the topic. Energy consumption, and that's why the train is becoming more lighter, more efficient traction systems, aerodynamic friendly, because this is about the high speed. The new high-speed trains is about aerodynamic, reduce by the increasing speed what the aerodynamic brings on the terms of friction and consumptions. Also, this is indirectly as industry provider, as GTRA, advise operators and investors to use a system which is fit for purpose. Go for high speed doesn't make sense sometimes. We talk about 3 airports, for example. Doesn't make sense to put a bullet trains where you stop 5 or 8 times. You will use too much energy. 50% more energy, by the way. 50% more energy if you look at the comparison. But the same, typical on the product. Product must be efficient in this sense, and also attract sources of energy which are carbon neutral. We are talking about hydrogen and batteries, but this is always the question, we discuss it. Today, from the technology point of view, you can cover only with these technologies a niche operation where electrification doesn't make sense, but there is no way to avoid electrification. No way to avoid electrification. Gentlemen and ladies and gentlemen, you will not get rated power. You need by the locomotives at least 4 megawatt to pull the cargo. How you do it with batteries? Dual mode is only to bridge in between. Dual mode helps. Battery driven, there is also dual battery driven locomotives, where a lot of operators in Europe start to use them. Battery driven and electrical, or battery driven and diesel, or diesel and electrical, depending how they operate. Battery, very often the operator use it to get out from their own depot to electrify track, because they can not afford to electrify their depots and their facilities. They get access to the main line, and they use the batteries for that, a shunting purpose, and so on and so on. Hydrogen, yes, but in the moment, and you look to the solution, we're talking about the realistic approach. All the manufacturers produce commuter trains, small commuter trains, like a small array buses, no? to commute, and the distance is up to 1,000. Yes, and they run whole day. One tank, because the question also how to get it, hydrogen. They run whole day, this 1,000 kilometers per day, and they come to the depot will be tank. Or battery trains, also those battery trains, by the way, running, commuter trains running with batteries. Also, 100 kilometer distance, and on both end is fast charging station. Coming in, charging, coming back, charging, always recharging, all like in Qatar Education City. Qatar Education City. You see that there's trams running without overhead catenary, but the docking in and each station has high cap, charging, batteries is permanently charged, and high cap capacitor. This is allowing without electrification between. So this solution makes sense, yeah. But also to understand, they are also costly. That means industry follows advices, but also industry has the obligation to also give feedback. What does make sense in terms of technological point of view? Yeah.
Okay, thanks, Thomas. The next question will be for JR Freight. Of course, JR Freight serves many customers. Yes. Okay, and then my question is that, do your customers care about decarbonization, and what are the activities that you have with your customer regarding decarbonization?
Okay. Thank you very much. About my customer, we have two type of customer. In Japan, to use our service, freight railway service, the company needs a license from government named freight forwarder. Okay. Yeah, and freight forwarder are mainly a logistics company, and we directly contract with freight forwarders, not our second stakeholder, for example, shippers, like manufacturers or factory or agricultural farmer or something. This is our second stakeholder, our second customer. And recently, our second status focused customer, shipper, manufacturer, or agricultural farmer, request transporter like a truck company, railway company, and shipping company to open the CO2 emissions, something, some data. And the reason is that the second customers need to themselves open how they reduce CO2 emission, decarbonization. Yeah. So our first customer, logistics company, need to try to open and also decarbonization. Yeah. So yes, we have we JR Freight have two type of customer, and we are direct customer. Logistics company first request from our second customer to reduce and open CO2 emissions decarbonization. Yes.
Okay, good. So that's the way that you do it in Japan. So, my last question would go to Dr. Visan. So I would like to ask you about the challenges or the obstacles that you can see in the carbon, in reducing carbon emission. So, you can take the case of hydrogen. What are the challenges of using hydrogen in the transportation sector?
Okay, thank you for your question. It's very challenging. To be, because of course carbon neutrality is our goal, but to achieve this one, I don't think we have only one solution that can fit all of them. It has to look at it in many solutions to fit for this problem. Of course, we have to increase the usage of the renewable energy. This is because right now Thailand is very obstacle for that, because right now Thailand is 80% of the power is come from oil and gas. That is also will cause a lot of carbon emission. In order to do that, I think we have to come up with a lot of policy maker and the way to persuade people to install the renewable energy for that, because right now the cost of the solar panel or something like that is way cheaper in the past, but the problem is that for the household or something like that, if we don't use the electricity from the solar panel and we sell it back, it's a lot cheaper compared to we buy it from the grid. We buy it from the grid is about 5 baht, but if we can sell it back, it's just only 2 baht, something like that. That is not making people want to it's kind of stagnant, and we also need to make it everything more efficiency. Of course, as Mr. Thomas said about that, we need to have the train is more efficiency. We need to increase the efficiency of that. As for the everything, I think it will help to reduce the carbon emission.
Yeah, I think it's exactly the same point that Thomas has about the holistic approach to I mean, everyone must help. Yeah, government sectors and policies and all that. So I would like to conclude our panel discussion by some remarks, okay, on each of your presentation. So just to recap what you guys just have said, have just said. So for PTT, decarbonization strategy focus on, of course, renewable energy sources and also biofuels. And then not only that, PTT will do reforestation, 2 million rice, very impressive. And then PTT also focus on carbon capture technology, and then also invest in renewable energy sources, and also look at hydrogen production as well. Of course, you have the test of fuel cell vehicles at Utapao Airport. Okay, and also PTT is the main provider for biofuel for the SRT trains. So that is PTT presentation. For Thomas from GTRA and Siemens, of course, Thomas focused on the GTRA focus on net zero carbon emission. And then Thomas also said that we should look at the causes of the problems, the overall causes of the problems, and practical ways to solve them, not only not focus on only one single element of the problem. So that is very nice and of GTRA to suggest that to us. And of course, Thomas also shows that technology can be a very important part in carbon emission reduction through the introduction of the new types of trains, through the improvement on characteristics of the train, aerodynamics, and all those all sorts of things. And actually Thomas showed one example at OBB in Austria that it can practically be done if everyone helps. Yes. And then for JR Freight, of course, JR Freight is the main, actually the only freight operator in Japan. Yes. And then, of course, very good to provide the statistics of the energy uses, in the company. And then JR Freight use efficient locomotives. And then most of the locomotives of JR Freight, they are electrical type. They are the electric type already, so it becomes quite clean. And from the statistic that we can see, Of course, the rail transport provide probably the best carbon emission rating in terms of land transportation. So it's quite impressive. Besides, also, I mean, I'm pretty impressive with the mark, you know, the eco rail mark that provide to the products that use rail transportation. So that's some sort of the soft power things that actually we can relate very directly to you know ourselves, you know, that hey, we are helping our country to go green on that one. So this one is very, very nice. And last but not least, NTech focus on the hydrogen for the transportation sector. And then Dr. Visan mentioned about the comparisons, okay, between hydrogen and other types of energies. And also, Dr. Visan also point out that we may be able to use the white hydrogen, okay, for good use, provided that we can find a way to efficiently transport the hydrogen, and that will be something that we should be looking forward to working on it in the near future. Okay, so I think since the topic is very interesting, we ran like 9 minutes over time. I'm so sorry for that. But in conclusion, I would like to thank all the panelists from PTT, from GTRA Siemens, from GR Freight, and also from NTech for giving me and the audiences some good information and something to think about in the future. Thank you very much. Okay. So we have some souvenirs to the panelists, and then we have some we have a photo session.